So now let's talk about the case number 5 of conjugation, which is known as back bonding. So in case of back bonding, there is a lone pair and there is a positive charge over here. Now lone pair gives this electron to the positive charge and it forms a positive charge over here. And let's say we have a CH2 plus and OH. Here we have lone pair and it gives the lone pair to it. So it's CH2 double bond O positive then H. Now we have further cases of examples of this particular case is known as back bonding, when a positive charge is in conjugation with a lone pair, right? So when we have CH2 positive with N and we have H and CH3 methyl group, then it is a lone pair is over here and it will donate its electron pair. Now CH2 double bond N, H and CH3 plus. CH2 positive, then S, then H. And then CH2 double bond S plus, then H. And then there is a lone pair and there is a positive charge. So when this gives the electron pair, then there is a positive charge. Now we have CH2 positive, then F has lone pair. F will give its lone pair and it will form CH2 double bond F positive. Now we have some questions regarding that. First, we have nitrogen and we have hydrogen. We have to identify the conjugation and draw the resonating structure regarding that. Third, it is like this: NH2 is a lone pair with BH2, and fourth, like we have NH, BH, BH, NH, and BH. And we have NH. These two examples, but you can do the two examples more. Like example number 6, you can do like aluminium, OH and H and H. Seventh example, you can do like CH2 plus, and it is a lone pair over here, and it will form two types of resonance. So these 7 examples, you have to pause the video and try to answer by your own how to solve these problems. Now, first of all, let's say we have a lone pair on nitrogen, and it will give its lone pair to that. So it will form N positive. First of all, why we are doing so much problems? Because these problems, it will make you a very fluent practice towards the topic, and you will be able to identify the problem and solve it with very quick response. So the negative charge will donate its lone pair to boron, and it will be CH2 double bond B negative H and H. And B has a lone pair. NH2 will donate NH double bond B H H. NH2 positive and BH2 negative. Now here in the case the lone pair will donate its pair to the boron. So N double bond B, N double bond B, N double bond B, H H H H H and H. Then the positive charge on nitrogen, negative charge on boron. Nitrogen, boron, nitrogen and boron. Now there is a sixth, the fourth. This fourth problem. Now let's say which is the fifth problem. Fifth problem is positive, positive and positive. Now here aluminium oxide has a lone pair and aluminium has a p orbital. So it will form HAl, H double bond O positive, Al negative. Now here in lone pair, it will donate electron pair, and here on the both of sides, CH2 double bond N positive. Here it is positive, and CH2 positive N positive, and this. Now here it is a lone pair. It will donate its electron pair O, O, and O. So here it will be a lone pair over here, and the positive charge is on oxygen. So there are various type of examples of back bonding. Now, is it possible always with p orbital? It is possible to always resonance with p orbital? No, there might be some case where it is with d orbital. So we can type it as a case sixth, back bonding with empty d orbital. How empty d orbital could have bonding? We have seen all the cases of empty p orbital, but here we have a lone pair and we have empty d orbital. That should be the case. So how when it's possible? Like CH2 minus and F has a lone pair. So will it resonance? No, it will not resonance because F don't have any empty p orbital. F don't have any empty d orbital. Sorry, F don't have any empty d orbital. So it is not the case of that. Now, when it is possible, if we, like how fluorine is 1s2 and 2s2 and 2p5, so there is no empty orbital in the shell. But if we see the resonance like CH2 negative as a Cl, so it will form a resonance. It will donate its electron pair CH2 double bond or Cl negative, and Cl has 1s2 and 2s2, 2p6, 3s2, 3p5 and 3d0. Now whenever we have N and Cl, H and H, so here also lone pair, it will donate its lone pair to N double bond Cl positive and negative. Two hydrogens are there. So that's how we have seen all the cases of conjugation. So these all were the cases of conjugation, and now there is some types of resonating structure, right? There are two types of resonating structure. We call it as a equally contributing and unequally contributing. There are more that segregation or classification. Like we have how many resonating structure, including all this conjugation. We have two types of resonating structures. One is called the equally contributing, and other is called the unequally contributing. So what is equally contributing? What is unequally contributing? Like like we can say that HC double bond O negative. When we draw its resonating structure after the conjugation, it will form HCO negative double bond O. So this is called the equally contributing, because both are like similar structure. Both structure are similar. But when we talk about like CH2 negative C double bond O CH3, in this case we can write it as a hydrogen to compare it very well. So in that case CH2 double bond C O negative then H, that is unequally contributing. It is unequally contributing. It is unequally. Why it is unequally contributing? Because one time the negative charge on carbon, one time negative charge on oxygen, but here one time negative charge oxygen, and both the time the charge negative charge is there on oxygen. Now we have some more structures like of equally contributing, like we have carbonate. If we draw some equally contributing, we have benzene first of all. Benzene has two structures, so it is equally contributing. Now again we have carbonate ion. Here it is carbonate. It will go in resonance like this. So it will be CO negative or double bond or O negative. Now it will go in resonance like this. So here also see O negative and double bond O. So here we have three resonating structure and all are equally contributing. Now one more R S double bond O then O negative. We have three types of resonating structure over here: O negative double bond O and double bond O, and R S O negative double bond O and double bond O. These three types of resonating structure are there. Now what is unequally contributing? Unequally contributing is CH2 plus, then O, then H. So this will go here and CH2 double bond O plus and H. Now when positive charge on carbon then oxygen, so it is unequally contributing. Particularly in that case also, if you see that there is a O negative double bond O and positive, that is also unequally contributing, because in the first structure there is no charge and in second structure there is a negative charge and a positive charge.